Welcome to Shaping the Future. This interview is with author and Cambridge polarised scientist Professor Peter Wadhams. We discuss the common exponential factors that exist between the COVID-19 pandemic and in the positive feedbacks of the changing climate system. We also discuss the urgent need for carbon drawdown, or greenhouse gas removal as it is also known, to tackle the excess burden of 1 trillion tonnes of pollution that humanity has pumped into the biosphere. Professor Wadhams is a leading authority on polar ice climate and is currently guest lecturing at Turin Polytechnic in Italy. This interview was recorded in May 2020 during the lockdown, but has relevant input from Peter about how we must consider action to shape a better future. Thanks for listening to this podcast series. We have many more interviews being recorded, discussing the most pressing challenges that humanity faces regarding our own survival. Subscribe on any major podcast channel or on YouTube to stay up to date. Peter, it's good to see you again.
Good to see you.
Can we start just by, in terms of the virus and the pandemic, do you see parallels between them? Is there anything that you think we can learn from this, or that you've identified?
Yes, I think there's a lot of things. I mean, firstly, they're both disasters, but they're disasters on different timescales. The virus is threatening everybody every day. I could get it today and I'd be dead in a week. But the climate change, it is an urgent disaster, and people are starting to realise that now, and they're declaring climate emergencies, but still not taking the kind of actions that you would take if you really believed there were a genuine emergency, rather than you wanted people to believe that you declared an emergency because, or in the case of Theresa May, because people were upset that she didn't meet Greta. So she thought she'd declare a climate emergency to distract attention. But the timescale is different, but the way in which the virus acts and the way in which climate change acts are very similar. In fact, I've been writing articles about this. The first thing is that it's in the early stages, it's an exponential growth. And this has been the case for climate change, but people haven't recognized it. And I think there's a famous American scientist who died recently who said one of the biggest problems of mankind is his inability to understand the exponential function, because it breeds complacency, and it's bred complacency in organizations like IPCC. Climate change starts out sort of slow, just like, for instance, sea level rise, the rate of global sea level rise. The rate is increasing, but the rate is increasing slowly. So you initially think, oh, well, we've got a few decades before we really need to worry about being inundated. But then when the exponential gets to work, there's an acceleration which continues to accelerate and takes you way beyond the state at which you can cope. And
when I first spoke to you, it must have been about 8 or 9 years ago, around that time when we did the first interview, we did a lot of talking around sea ice. It was always much more of a future problem. I mean, I know you were never saying end of century or anything like that, but it wasn't something that we were necessarily in the eye of. And in the last few years, hurricanes are a good example. But then when we started seeing the Amazon on fire, then Australia on fire, that really tipped the balance, didn't it? I mean, yes. Suddenly it was irrefutable, it's undeniable. We have a huge problem and we're right in the middle of it. And it's almost that in the last 5, 6, 7 years, what was going on anyway, which we couldn't see, just suddenly started showing really violent symptoms. And would you say that's part of that exponential thing?
Yes, and it is because every change is exponential. And the classic case, of course, is the carbon dioxide content of the atmosphere curve from Mauna Loa. I mean, that's a perfect case of an exponential function. And it doesn't matter how many international agreements are made, how many IPCC reports come out, or even the Paris Climate Agreement. Not a single one of those things has had the slightest impact on the rate of increase of CO2 in the atmosphere. It just goes on increasing exponentially. And as it goes on increasing exponentially, the rate of everything, the rate of change goes up. And we have that with the virus as well. And the two are very, very similar. The difference is that with climate change, there is nothing to stop this positive exponential from carrying on, both in the case of carbon dioxide content and in the case of sea level rise, methane content in the atmosphere, intensity of hurricanes. Everything you look at is increasing exponentially. And that means disasters are going to be hitting all together, right and left, at the same time, because we failed to take account of the fact that the changes that are happening are all exponential changes.
Sure. You referenced earlier the Arctic sea ice. This year's on track to be one of the hottest years on record. The Arctic, we know that that's heating rapidly. What have you noticed in recent times about that? Because that's another one of these things that's out of sight, out of mind, and yet completely integral to the way we live.
Yes, my most recent experience was with actually the Greenland ice sheet. And I was up there on August the 1st last year. By accident, that a visit I was making coincided with this date, which was the date when there was more melt from the Greenland ice sheet than on any previous day since records began. And that was 12.5 billion tonnes of ice melted on August the 1st last year. So I was standing on top of the ice cap, surrounded by waterfalls, violently flowing rivers, which never used to happen on the Greenland ice sheet. You didn't even get any melt in summer because your elevation meant that it was too cold. But now you can see the ice cap vanishing before your eyes, and with other accompanying effects, like the fact that the ice is vanishing so fast, but leaving behind all the dirt. So the ice cap is getting blacker and blacker. So there's black ice, which is the dirt and bits of living matter that are left behind, makes the surface darker and darker, which means it melts faster. Before your very eyes, you see an acceleration of the warming effect of the ice cap and the fact that it's melting already 6 times as fast as it was 10 years ago. So that's going to accelerate, or is accelerating, the rate of global sea level rise. And when we see that also happening in the Antarctic, with various glaciers getting detached from their bed and the potentially large catastrophic outputs of ice into the ocean, then we can see that the global sea level rise is not something where you follow this in very, very complacent view that IPCC used to have, that it will just go on rising linearly, but it's rising exponentially, and that rise is accelerating just like the death rate from the virus in America.
With the death rate in America and the virus, there are measures we can take. Even if we take them late, we can still get this under control, because even if you've got a 3% death rate, which is colossal, I mean, it's massive, but it's not going to cause a huge wipeout of humanity on the scale we're talking about with the climate. This is where the two diverge, because one does have actions you can take, and the other one, we don't have any countervailing forces. I mean, even if we reduce our emissions, to be fair, 2050 sounds a bit late to me. Do you see countervailing forces where we can actually stop this?
Yes, well, only one, which is air capture, direct air capture, taking dioxide out of the atmosphere. It's the only countervailing force I can think of, because everything else, which people have always talked about emissions reduction, that's the way we're going to deal with the climate problem, but it doesn't deal with it at all. I mean, I really can't understand why people got so obsessed with emissions reduction, because however good you are at reducing emissions, you're still increasing the level of carbon dioxide in the atmosphere. And if you increase the level, then you're increasing the global temperature. So we'll still be getting global warming. It's just that we'll kind of roast to death more slowly than in the past, than if we didn't take any action. So the only way that will work is to actually take the carbon dioxide out of the atmosphere. And if we can do that, it's the equivalent of finding a vaccine for the coronavirus. You're removing the cause of the nasty thing. And the foundations that are, I think, most active at the moment about this, the Climate Repair in Britain and the Climate Restoration Foundation in the US, they're saying focus on taking the CO2 out of the atmosphere. It's going to be a massive job, but it can be done. Technically, it's easy to do. It's just that you have to do it on a huge scale, and you have to do it at a cost that's acceptable. But you can do it, and you have to do it, because then we can get the CO2 level down, and then we've solved the greenhouse effect.
So if that's our global vaccine for climate, have you seen any options that look like they might actually deliver so far, even in development?
Yes, at the end of last year, I was going around in the States and visiting some of the places where CO2 removal is being done. And in fact, here in Italy, there's one place where this is being done by the Polytechnic that I'm working at Turin. But the ones I was visiting in America, there's a couple that are very, very promising. One is a company called Blue Planet in Los Gatos in California, where they're taking the CO2 out of the atmosphere is the fairly easy part. You pass the air over an amine or hydroxide. There's an absorber, absorbs the CO2 out of it, then you have to regenerate the CO2. And so the problem is not so much taking the CO2 out of the atmosphere, it's dealing with this massive amount of CO2 you have after you've been doing it. You're taking 40 or 50 gigatons per year out of the atmosphere. That's just to stay where you were. You want to take more out to get the level down. They've got a way of doing that, which is to combine it with calcium oxide and turn it into artificial limestone. And the world actually does need artificial limestone because the world's running out of sand for cement. And when you grind up limestone, it's the right kind of sand to use in cement.
Okay.
So that's a promising thing. The other one, of course, is Climeworks, which is the Swiss company working in Iceland, pumping the CO2 into huge cavernous spaces under the mid-ocean ridge in Iceland. That's great. And then I should mention the only effort being done in Europe is actually here in Italy, in fact in Foggia, which is in southern Italy, where Climeworks has built a pilot plant for taking CO2 out of the atmosphere using wind power, because it's a very windy site on the Adriatic, and then doing the same thing as the company in the US, which is actually turning it into something.
Yeah.
And in this case, it's fuel. So that's really great. And the Turin Polytechnic, which is the place I'm visiting scientist at this year, has taken on that job of developing that system with Climeworks in a partnership.
Okay, that sounds very promising. What always shocks me is the scale. You said, 40, 50 gigatons, 40, 50 billion tons of this stuff.
Yeah.
And that's annually. And that's to tread water.
Yes, the scale is enormous. But when you think about these methods, there's a lot of methods which you can't scale up. They're great ideas that people come up with. But then when you think about how can you scale those up to planetary scale, there isn't any way. It's like afforestation. Let's get rid of CO2 by planting huge areas of forest. It turns out the area of forest you'd have to plant is about the same size as the planet. And so you wouldn't have anything else except forest. There's another method of getting rid of CO2 by spreading olivine rocks, which actually absorb CO2. You spread them on beaches all over the world. But the number of gigatons of olivine rock you'd have to spread per year is unbelievable and impossible. So,
okay.
So there's some of those, and other ones like trying to reconstitute the Arctic sea ice by spreading white stuff over the surface to encourage freezing. It's all well-meaning, but when you do the sums, it's impossible.
Yeah, I can imagine.
But air capture does work, and it can be scaled up. It's a bit like injecting clouds with small particles and marine cloud brightening. That would work. So there's things that will work but cost a lot, and things that wouldn't work at all. So I think we should focus on the things that work, even if they cost a lot. They have to be done.
That's a climate vaccine.
Yes.
Okay, this year, 2020, I mean, especially for Brits, was climate significant because of COP26 being held in Glasgow? That's been long grasped, or whatever you want to say, in a way that lets a lot of momentum go on the policy side and the activists and everyone. There's a lot of young people now who are really picking up the mantle and running. The virus is such a unique experience that it's made people very self-reflective. From the perspective of a climate scientist, and you've engaged a lot with activists and people from all kinds of climate backgrounds, people in this field, and even the denier side. Coming out of this, what are your thoughts of what are going to be the obstacles? What do we need to see, or are there opportunities? And this comes back to the point of this conversation in a way, is where we're sort of trying to think about the future and designing that future or shaping it in any way. Do you have thoughts on that?
Well, yes, the COP itself, it's a great pity it's been put off, because I was at COP25 in Madrid, and like you, I guess I was amazed at how little progress was made in Madrid. And yet those COP meetings are meant to be very, very important, because they're the meetings at which all the countries of the world come together and firm up their commitments to reducing emissions. You still have to reduce emissions as well as getting rid of CO2. Every country is supposed to improve its bid through being able to do a better job now with better facilities, and through realizing that we have to do a better job because the targets would not be met, and in fact are not going to be met otherwise. So COPs were very important, and the Madrid one was disappointing, and I think partly because everybody was kind of stunned by America's withdrawal, and of course Brazil's antics as well. But America, with just the sheer mindless, moronic stupidity of that act by Trump, just throws the whole world into a flurry of kind of despair, really. If the greatest country in the world can act like in such an infantile way, what hope is there? So that was what I suppose people felt despondent. And so one thing that in the future we have to have is get rid of Trump. And if the Americans are too stupid to do that, the world is lost. I mean, there really won't be much point in people trying to save the climate or save us from catastrophe, because we will be willing ourselves into catastrophe, a bit like Britain with Brexit.
The irony is the US is a big source of solutions for climate change.
Yes, it is. Yes, when it's not doing the solutions but creating more problems, then we really are in trouble.
You mentioned Brexit, it feels like a distant thing, but it is ever present, and Brexit was pretty much scheduled. The next blow to our sense of identity was scheduled pretty much at the same time as the election in the US and at the same time as the COP, which is a kind of asteroid moment.
Yes.
Maybe do you think that could be positive in some way, that there's a bit of space around there?
I guess a lot of people have said is that the virus has been such an economic catastrophe, and so many companies have closed down and industries have closed down, that when we open up again, it will be, first of all, probably impossible to open up again as things were. You can't go back. It's like the end of the First World War. Let's go back to the pre-war era. You can't. But also, it's an opportunity to do everything in a better way. Especially this applies to energy. With everything having been closed down, when you start up, then we can accelerate the changes, building new infrastructure with renewables, solar and wind, rather than building some more coal-fired power stations, which seems absolutely an anomalously stupid thing to do. But now, and people realise that, they might think, well, that's not a great idea. Why don't we greatly expand solar and wind? We can make a new start if we really want to. The virus, in a way, has cleared away a lot of the old stuff we were stuck with, the old infrastructure, the old way of thinking.
You mentioned coal, and of course coal is the pollution particulates in the air have been now shown to be linked to the rate of deaths from COVID-19 in certain places, which is another damn good reason to clean up our cities. I mean, Italy's cleaning up Milan.
Yes, in Italy, Milan, which is my wife's hometown, is a real case because, for instance, before this virus, we were supposed to get rid of our diesel car, which we bought some years ago because you used smaller quantities of it. And so it seemed an ecologically good thing to do. People didn't realise the big emissions of particulates. And now Milan is banning diesel cars. But at the moment, there's a very large death rate from the virus in Milan and less extent Turin. And it has been identified as being due to the virus attaching itself to particulates in the atmosphere, and that they're particularly bad in Milan because of being such a big industrial city.
Yeah.
So that would be an opportunity to improve the atmospheric quality, and that would be good from a health point of view.
That's very good. So two main takeaways are carbon capture from the atmosphere is the vaccine for climate change, and rethink energy policy as we emerge from this crisis is absolutely critical. Okay, well, thank you very much. It's been really good to talk to you.